Hey guys, this is the fourth video in the Chapter 8 hypothesis testing series. The first video was, if you haven't watched those videos, please watch them. The first video is 8-1 Part 1, Basics of Hypothesis Testing. The second one you should watch is 8-2, Testing a Claim About a Proportion. And then the third video you should watch is 8-3, Testing a Claim About a Mean. So this is the fourth one, which should be the last one you would watch. All right, so in this video, I recommend you, if you're following along, to look at this part of your notes where 8-1 Part 2 hypothesis testing. We're going to talk about calculating the test statistic without using like the 1 prob z test or the t test or the z test, right? This is how you would calculate it without the convenience or the ease of using the TI-84 calculator. We're also going to talk about calculating the p-value. We're also going to talk about um, calculating the critical value. And then the last thing we're going to talk about is something called the type 1 and type 2 error. Okay, so we're going to go ahead and jump right into it. So I'm going to take you guys back to this problem in section 8-2 about the virus treatment problem. So I want to look at like how do we get this value? When we use 1 prob z test to get these two values, but how do we get these two values? All right. So let's go ahead and take a look at the test statistic first. So first thing is you got to know, well, what parameter are we dealing with in this hypothesis test? So take note that recall that we're dealing with a proportion, right? That's why we have the P here. The P here represents population proportion. And in this problem was like the population proportion of those who recover from the virus, if you guys remember. All right. So that's the first thing we got to know, that it's dealing with a proportion. So here, down here, we're going to calculate the test statistic. So test stat using the formulas, right? We have to know how to use the formulas. So for proportion, the parameters of population proportion, it's a z distribution. These requirements are usually, in the homework you guys work out, they're usually met. You don't have to check the requirements here. And then the formula for the test statistic is right here. So the test statistic is z equals this. That's p hat, which is a sample proportion, minus p, which is a population proportion, and it's divided by the square root of this. All right, so I'm going to rewrite all of that down here. So the formula is z equals p hat minus p. Okay, and then divided by the square root of p times q divided by n. Okay, so here we have, let's see, p hat is p hat. Well, let's see. P hat is a sample proportion, so we know that's going to be x over n, right? This is my x, this is my n. So p hat is x over n. So we're going to go 114 divided by 158. Let's go ahead and calculate that. So that's going to be 114 divided by 158. So p hat is approximately 0.722. That's what we have there. And I rounded to 3 decimal places. If you want to be safe, we can round it to 4 decimal places, right? These are intermediate rounding. So this is, again, these are not final answer rounding, so it's always best to go a little bit further if you want. So 4 decimal places looks good. All right, so that's what that value is. So I'm going to move this over here just so I have space here. So that's going to be 0.7215 minus P is always a value that's in the claim. So in this case, the claim has 0.64, right? P is equal to 0.64. So we're going to use that. So that's going to be 0.64. And then we're going to divide by the square root of P, which is 0.64, times Q. Q is always equal to 1 minus P. So 1 minus 0.64. which is equal to 0.36. All right, so 0.36, and then we're going to divide by n. So n is 158. So all of that down there in the square root. So I'm going to show you guys how to input this into in as one expression. And it's always a good idea when you're writing this out to put a set of parentheses here, just so you remember that to put a set of parentheses when you're typing it into the calculator. All right. So again, if you want to put it into one expression, you have to put those set of parentheses around the numerator. Otherwise, you're going to get it the wrong answer. So parentheses 0.7215 minus 0.64, and then close parentheses, right? And then we're going to need the division bar, which is just the fraction bar, which is just a division sign. And then square root. So we're going to call the square root by clicking second x squared to call the square root. Inside that, we're going to type in 0.64 times. I can do the multiplication sign. I can do a set of parentheses. It doesn't matter. So times 0.36. And then inside the square root, we also have a divide by 158 and escape out of that. And that should do it. So press enter. And that's how we get the 2.13. That's how we get the test statistic right there. So approximately equal to 2.13. All right, so that's how you get the test statistic. Now, as for the p-value, I'm actually going to delete this stuff because I'm going to need this space to find the p-value. So let's go ahead and take a look at the p-value next. So the p-value it depends on if we have a left tail test, a right tail test, or a two tail test. So left tail, right tail, two tail is dependent on the alternative hypothesis. So if we go to, actually, let's go to the overview. If you go to the overview of the hypothesis test, if the alternative has a less than sign, it's a left tail. If the alternative has a greater than sign, then it's a right tail test. And if the alternative has a not equal sign, then it's a two tail test. Right. So in this case, what we have here is the alternative has a greater than sign. So for the p-value, we have a right tail test. So it's a right tail test, which means that the p-value is the area to the right of the test statistic. So wherever the test statistic is, it's the area to the right. So the test statistic in here, this is actually a z distribution, right? That's why we use the one prob z test. Whenever you're dealing with proportion, it's always a z distribution. So this test statistic should have been z equals. And because it's a z, we know we're dealing with a standard normal distribution. So the p-value is the area to the right of the test statistic. So the test statistic is 2.13. The p-value is the area to the right of that. And we know this is z distribution, so we know that this is standard normal distribution, which means the mean is 0, standard deviation is 1, right? This is all stuff from chapter 3, which seems a long time ago. And how do we find the area to the right of a standard normal distribution? So that's I'm taking you back all the way to chapter 6, right? For a z distribution, for an area under the curve, we're going to use normal CDF. All right, so we're going to use normal CDF. If you guys recall, normal CDF has 4 inputs. So the first input is the lower. So the lower bound is the lowest number under the shaded region, the lowest z value under the shaded region, that's 2.13. And the upper bound, it shades, theoretically, it goes all the way to positive infinity. So we're going to put 9999. And then don't worry about this 6, this was just the page number. And then the mean is 0, standard deviation is 1. All right, so let's go ahead and take out the calculator and see what we get there. So we're going to go second vars, normal CDF. The lower is 2.13. The upper is 9999, and that looks good. So we're going to click paste. And that's the p-value. So the p-value is approximately 0.0166, which is very close to what we have here, right? Very close to what we have there. It's different. The reason why it's slightly different from what we have is because we rounded this right here. So if you don't round the test statistic, you should get a more accurate number, or no, more accurate p-value, right? So that's how you find the p-value. If it's a two-tailed test, and I'll go ahead and do a two-tailed test as well, just so you guys know what that looks like. But whenever it's a two-tailed test, just know when we find when we run the like either normal CDF or TCDF, we need to double it. We need to double it because it's the area in two tails. Okay, so let's do one more problem. Let's take a look at 8-3, a problem that we did in the last video for this one. So the test statistic, we're going to look at how to find that. So using the formulas, we're dealing with a mean, right? So just to recall of this problem, we were looking at the mean. The claim involves a mean, which means, and it was a t distribution because sigma was unknown. So for a parameter involving a mean for t distribution, because sigma is unknown, we're going to use this formula: t equals x bar minus mu divided by s divided by square root of n. Right? So I'll go ahead and input this. So x bar is, let's see. So x bar is the sample mean, which is 4.8. So I'm not going to write it out. I'm just gonna go ahead and type it in. So we're going to open up parentheses, right? So if you go back here, we're going to open up a parentheses and then put x bar. So x bar was 4.8 minus the population mean. So the population mean is always the value in the claim, right? Mu equals 5. So that's going to be 5. Subtract 5 and then close parentheses. And then the fraction bar. So we need the fraction bar or the division sign right here. Actually, we're looking down here. And then it's s divided by square root of n. So in this case, because this is a complicated or a complex fraction, I'm also going to put a set of parentheses down here for the denominator. So I'm going to open up parentheses, and then it's going to be s, which is a sample standard deviation. Sample standard deviation s is 0.68. So 0.68. And then we're going to divide by the square root of n. So if you take a look at this, it's divide by the square root of n. All right, so divide by the square root of n. So n is 24. And then just exit out of that and then close parentheses. Just like that, press enter. And that's how we get this right here. T equals negative 1.44. Okay, to find the p-value, we're going to use a function called, well, first of all, we got to decide. So for the p-value, we have to decide whether it's a two-tailed test, a left-tailed test, a right-tailed test, or a left-tailed test, right? So in this case, because the alternative hypothesis has a not equal sign, right? It's going to be a two-tailed test. Oops. So the alternative has a not equal sign, it's a two-tailed test. All right, so for a two-tailed test, the p-value is the combined area of the two tails. And I wrote down here is depending on where the test statistic is, you're going to find the area either to the right or to the left. And then once you find that area, you're going to double it because the area is a combined area of two tails of equal value. So what do I mean by that? So let me draw you guys a picture. So this is a t distribution. Notice how this is a t distribution because the test statistic was t and sigma is unknown, right? So given a standard t distribution, which looks a lot like a normal distribution, and the test statistic is negative 1.44. So the p-value is going to be the area to the left combined with an area to the right of equal value. So the p-value is the combining both these area. Now so it's a two-tailed, right? In a normal distribution, we would use normal CDF to find, in a Z distribution, we would use a normal CDF to find the area in this tail and then just double it. In a T distribution, there's a same function called, or similar function called TCDF. So TCDF takes 3 inputs. So we're going to navigate to that. We're going to click second vars, and TCDF takes 3 inputs. The first one is the lower. So if we're trying to find the area here, the lower is negative infinity, right? So we can put negative 999.9. And the upper is negative 1.44. And the degrees of freedom is going to be the degrees of freedom is n minus 1. So in this case, n is 24, so that's going to be 23. All right, so let me just go ahead and write down everything. This is negative 9999. This is the lower, and the next input is the upper. That's negative 1.44, right? So again, visualizing this, this is the rightmost point. The leftmost point is negative infinity. So this is our lower is negative 999. Our upper is negative 1.44. And the next value is our degrees of freedom, which is the df is equal to n minus 1, which is 23. So df is n minus 1, which is 24 minus 1 in this case. All right, let's go ahead and evaluate, paste, and that's how we get the p-value. Not quite, right? Why is this not the p-value? It's because we got to combine it with this side as well. And this side is the same value. It's also 0.0816 dot dot dot. So from here, I'm just going to multiply by 2. So multiply by 2 to get that the p-value is approximately 0.1633. All right, so using the TI-84 with a T, using the t-test, right? Here was our p-value, 0.1631. And using this route, we got 0.1633. Now you might say, well, how come we didn't get the same? It's because we rounded here. We rounded this test statistic. Had we used the unrounded test statistic here, this right here, we would have gotten this value here. Again, as long as you're close enough on the test, it's going to be multiple choice. Just please choose the one that's closest to what you get. Okay, and then finally, let's look at the critical values. So critical value is where, well, let's take a look at the notes. So critical value, the way we find critical value is the following. It also depends on whether it's a left-tailed test, a right-tailed test, or a two-tailed test. So because this is a two-tailed test, let's go ahead and stay with this problem. Because it's a two-tailed test, let me give myself some space. So let's do this, and let's critical value down here. Because it's a two-tailed test and it's a t distribution, there are two critical values, positive and negative t sub alpha divided by 2. And for that, we're going to use inverse t. So we're actually going to find the critical value using 2 methods. We're going to figure it out using inverse t. So inverse t is the first input is 1 minus alpha divided by 2. So that's going to be 1 minus alpha in this problem is 0.10, right? It's right here. So 1 minus 0.10 divided by 2. And then degrees of freedom. Degrees of freedom is 23. All right, so I'm going to show you guys how to do that. For those of you guys who have the 84, you have the inverse t function. For those of you guys who do not have the 84, you do not have this function. So we're going to go second vars inverse t. We're going to go 1 minus 0.10 divided by 2. Degrees of freedom is 23. So got to be careful. The critical value, there's two of them. There's the positive one, 1.71, and the negative one, negative 1.71. So there are two critical values for a two-tailed test, positive 1.71 and negative 1.71, right? That's what this plus or minus is telling you. There's a positive one and a negative one. Okay, now you might ask, well, what about those of you guys who have the TI-83? Like you don't have that function. Well, you're going to have to use the t-table. So in that case, you need to use a t-table. And there's three things you need to know. You need to know that it's a two-tailed test, right? You got to know what alpha is. Alpha is 0.10. And you got to know the degrees of freedom, which is 23. So having all of that handy, you need to pull up the t-table. Okay, so here I have the t-table. You need those three things. You need to know that it's a two-tail. You need to know that alpha is 0.10. So we're in this column. And you need to know that the degrees of freedom is 23. So we're right here. So the critical value is 1.714, which is exactly what we have right here. Theirs has it to 3 decimal places. Follow the round off instruction for um, what the question is asking. So that's going to be 1.71. But know that because this is a two-tailed test, there's the positive one and a negative one, right? All right. And then finally, for this problem, remember how we use the p-value method to figure out whether we reject the null or fail to reject the null? And that's where we compare the p-value to alpha. We're going to look at the critical value method. So critical value method, in that method, we're going to compare the absolute value of the TS to the absolute value of the CV. So the TS is the test statistic and the CV is the critical value. So absolute value, that is the distance from that number to 0, right? So in this case, the TS, the test statistic, is negative 1.44. The absolute value from negative 1.44 to 0 is just positive 1.44. So if you don't understand absolute value, just remember it's whatever the number is, we're just going to change it to a